The United States Air Force and Department of Defense are pursuing a distributed capabilities approach for our nation's space assets, with the desire to move away from large, monolithic assets, creating instead the same capacity across swarms of small satellites. A significant barrier to this vision is the nation's ability to produce large numbers of highly complex spacecraft extremely quickly and in a cost-effective manner. AURA's technology addresses a key component of that need: the rapid printing of satellite structures with embedded electrical buses that can handle both signals and high-power transmission. With AURA's technology, we can produce lighter-weight satellite structures with higher reliability, accelerating delivery time, and reducing costs. Once the layout is defined, the panels can be delivered in less than a few weeks, dramatically reducing lead time and manual labor. Mounting solutions for payload can be directly integrated into the structure with less bracketry and fewer fasteners, while custom designs can be printed quickly without custom tooling and limited technical setup. But what sets AURA's multi-structure apart is the ability to eliminate wire harnesses for higher power connections, dramatically reducing labor for construction, assembly, and test, while also reducing potential points of failure with completely self-contained wiring, leading to more reliable overall system design and performance. The time multi-structure saves can eliminate missed launch dates with less performance risk. With additional funding from the AFWERX program, AURA will be able to raise the manufacturing readiness level, improve technical readiness, and quickly and efficiently begin low-rate initial production. Development will focus on integration of multiple processes into a single toolset with in-situ inspection to consistently ensure defect-free, validated panels at every print. Ultimately, AURA will produce a manufacturing line to work closely with research labs at Kirtland Air Force Base and cultivate engineering talent from the Keck Center additive manufacturing mecca at UTEP to continuously build on our next generation technology to the direct benefit of the warfighter.